Okay. Uh, yes, let us discuss about definite integrals. Earlier, we were completed complete chapter of the indefinite integral. Chapter means it's a one part of the integration. Indefinite integral is over. Now the definite integral, why we want to study the again definite integral? I told you in the previous section that every time we used to add c, and you were lots of confusions. Why he is going to add c oftenly? Then even though if we don't know the definite value of that function, then why should we add that function c? Then what is use of that? See, when you study the definite integral law, then there is no any uh, then there is no any use of that. So if we want application of that part, no, so we want a definite value or a fixed value for it. So here we are studying a definite integrals, correct? See, we define like this. First I write a simple definition. Actually definite integral, what we do is we write it as the sum of all the areas, but we study that indefinite in detail in the again next chapter, area under the curves. Here I just go through directly the definition. Suppose let f of x be a function and integrable in a to b, then we can call it as integration from a to b f of x dx. Look at this very carefully. Suppose you have an integration, you want to do an integration of a function f of x, we write it as integration from a to b f of x dx. See, you are restricted, the integration of a function means adding the sum of areas, you are restricted from a to b. Suppose you have here 1 to 100, you are restricting this to something 3 to 5 or 4 to 6 or any other number in between that one. Or else if you take complete set of all real numbers minus infinity to plus infinity, you are talking about 1 to 2 or 2 to 3 or any one particular area, one fixed area or fixed region you are marking here. So this integral, say for example you are getting f of x. Let us assume that the answer for this question you are getting capital F of x. Say sine is there, cos you will get. Cos is there, tan. Same thing, same whatever you do for indefinite integral, same thing you are also doing here for the definite. So then you say that you are integrating between small a to small b here. How to integrate this? You write it as integration of this function and simply you mention from where to where you are integrating. Then later on you substitute this upper value, that is f of b, minus substitute lower value, and this is what the definite integral. See, the difference between definite and indefinite is simply you are substituting the upper values and lower values, means lower limit and upper limit. Okay. And now when you want to in detailed structure of this one, say for example if I say integration from I equal to integration from a to b f of x dx. See, this is what we call it as lower limit. It is what we call lower limit. This is what we call upper limit. This is what we call upper limit, correct? And the same one, this is what we call integrand. There is no any change in the previous, just these two are additionally you are getting here, correct? For example, if you are integrating 0 to pi by 2 sin x dx. Suppose you are integrating a function 0 to pi by 2 sin x dx. What is the integration of this? It is minus cos x from 0 to pi by 2. Correct? Minus if I take outside cos 90 minus cos 0. I told you, you have to take once upper limit and another time lower limit. So upper limit you know very well cos 90 is 0. So this is minus 0 minus 1 because cos 0 is 1. So finally you get it as answer 1. Now this is a fixed value here. And you might feel that, okay, sir, in every time whenever I integrate here, I used to get C here, but you did not take C, then that's why the C is not there. No, it's not like that. See here, suppose you are taking, I remove this example. Suppose you are taking integration of a function, this one, as I equal to integration from a to b f of x dx. Let us you call it as you get capital F of x plus c. Let us assume that you are getting every time that is like that f of x plus c only, correct? So when you get f of x plus c, you say that it is from a to b, correct? What the rule tells us? Simply you substitute upper limit throughout this value minus lower limit. What is the upper limit? This is f of b plus c. This is upper limit minus f of a plus c, correct? And then plus c, this is minus c, both will vanish here. Every time in any case, c will vanish. What exactly you are getting? F of b minus f of a only. Yes, please note down this part. Note down this one. Note down this one. And then I go for a very important in this chapter is properties, because most of the problems what we solve, they are all based on the properties only. Okay, properties are very, very important, and if you know the properties, examples will be given based on the properties only. Okay, yes. Simply one definition and that one. That is also you know very well. Just explain to you. Remember, always lower limit is first value of the interval and upper limit is second value of the interval. Okay. Yes. And this time in the syllabus they have reduced. I told you the definition. Limit of a sum method, so that is not there, so it's lucky for us sometimes. Okay, can I remove this? Yeah. Now we go for properties of definite integrals. Okay. Properties of definite integrals. Properties of definite integrals, correct? Definite integrals. Properties of definite integrals. Properties of definite integrals, correct? You see, there are some 5-6 properties are there. They are very, very important for us. Whenever you are solving any definite integral problem, you need to know these properties. Okay. So the first property, what it tells us is, suppose you have integration from a to b f of x dx is there. अगर आपके पास इंटीग्रेशन फ्रॉम ए टू बी एफ ऑफ एक्स डीएक्स इज देयर, देन इट इज सेम लाइक इंटीग्रेशन फ्रॉम ए टू बी एफ ऑफ टी dt. What is the meaning of this? If you change the variable x by y, y by z, z by some other number, there is no any change in the value of the function will take place. That's why we call it as a dummy variable. Okay, let us solve this property. Okay, proof for this one. See here, I take this one first. RHS you can take or LHS you can take. I take LHS. LHS if I take integration from a to b of x dx it is correct. Simply I am interested where I have x, no, I want t. Let us I say that x equal to t. When you take x equal to t, this dx has to change into dt. So you can call it as dx equal to dt. Why? X का derivative dx, t derivative dt, correct? And very, very important thing in this concept here is you have to change the limits here. Now, when it was x equal to a, means when the variable was x here, the lower limit was a. When it becomes t, means x equal to a, if I put t is also a, that is, this implies t is also a. When it is x equal to b, no change, t is also b, correct? t is also b. Yes, I hope you can understand. Now look at this. The new variables looks like this. LHS equal to integration from a to b. Correct? No change. A becomes a only, b becomes b only. X becomes t, dx becomes dt. What is this? It is f of t and dt. What about this? It is called same or RHS. So here you can also call t is dummy variable. dummy dummy variable. Don't call it as a dummy variable. Okay? Dummy variable. Dummy variable. It is dummy variable. Yes. Yes. Please note down this. It's a first property. Very easy property. Looks like a dummy only. It is correct. What is there in that? But they may ask this question for 6 marks. 6 marks property will be there in previous question paper model along with the problem. Property plus problem they will add. In the 5 marks I told you indefinite integral property plus problem. Correct? Like this it comes in 6 marks. Big shot read. Yes. Then whenever you want to add two definite integrals, variable does not matter. What matters? Interval matters. Huh? Take care of this. I have changed x to t here, but I have not changed the interval. This is very, very important. Interval has to be same. Okay? Yes. Yeah. Next होगा ना? Yes. Remove. ಸ್ವಲ್ಪ ನನ್ನ ಜೊತೆನೇ ಬರೀತಾ ಬನ್ನಿ. Along with me only you write. So second property, if I have an integration from a to b f of x dx. By mistake someone do like this, he feels that array sir a b b a everything is same sir, I don't want to write a to b, I write b to a. Sometimes you feel like that, b to a let us write. Nothing is going to happen, only the sign of the integral will change. When you change upper limit and lower limit, the sign of the integral will change. How sir, how it is? How? Because in the final answer what you do? Upper limit minus lower limit. Here what happens? Lower limit minus upper limit will happen. Correct no? Yes. Solution for this part. Very simple. It is very, very simple. Now look at this. I take, let us, integration from the thing now. I equal to integration from a to b f of x dx. Integration from a to b f of x dx. ಇಲ್ಲಿ specific ಆಗಿ we don't do any modifications. Simply we go with the definitions of the definite integral. ಏನು ಅಂತಂದ್ರೆ, you know very well the answer for this question is f of b minus f of a. Correct? Definition ಬರೆದಿದೆ beginning. If the integration of this part is f of x, answer is f of b minus f of a. Suppose if I take minus common in these two, what I get? F of a minus f of b. Correct? Simply I have taken minus common. But the rule what it tells? Suppose if I write like this, anyone can say that it is upper limit and it is lower limit. If it is happens like this, leaving minus, anyone can say that this is upper limit and this is lower limit. Correct? So you say that it is minus of integration from b to a f of x dx. This is my RHS. Correct? Look at this. It's a very easy property. There is nothing else you are going to do in this one. So very simple it is. One thing you have to remember here it is, you need to remember अगर हमारे upper and lower limit change हो गए तो sign of the integral will also changes. What is you have to remember in the first property हमने जो पढ़ा है, that was very dummy. Sir, what is use of that, sir? See here, suppose you are doing so many big calculations In that, one is like this: a to b f of x dx plus another one is a to b f of c dc. One more is integration from a to b something f of d dt dt. Sorry, f of t I will take f of t dt. So you feel that this is all a different one. What I do? See, remember the property one tells you, so that you don't worry about the c dc t dt. They are all same. Simply you can add 3 times of integration from a to b f of x dx, or else 3 times of f of c dc, 3 times of a to b f of t dt. Correct? So what you have to understand from the first property is, even though the letter is different, if the interval is same, this is very very important, and then we can add both the functions. Okay? Yes. Now we are going for the property number 3. Correct? Third property. The thing goes very fast now. It's very easy. Property number 3. What the property number 3 tells us? If you have integration from a to b f of x dx. Sir, अगर आपके पास integration from a to b f of x dx है. Say for example integration from 1 to 5 f of x dx is there. मात्र ಈ ತರ ಇದೆ ಅಂತ 1 to 5 f of x dx. So then rule what it tells, you can split it as 1 to 2 f of x dx plus 2 to 5 f of x dx. Or else what you can do, 1 to 3 f of x dx plus 3 to 5 f of x dx. Or else 1 to 2, 2 to 3, 3 to 4, 4 to 5, any numbers you can split. So, the interval a to b can be split into any n number of terms. And sum of all that is always equal to this one. Okay? But very important thing, this 2 must be in between 1 to 5. 3 must be, 3 must be in between, 3 must be in between, belongs to 1 to 5. This is the same general property what it tells, a to c f of x dx plus c to b f of x dx, where c is a number in between, c is a value between a and b. Not necessarily only c. Any n number you can split. One property, to prove the property, one number I have taken here. Okay, this is very important. Yes. Now let us restart. See this property. Again, it is a very easy property. There is no any difficulties. Okay. Yes. So now look at this solution for this one. I will take first I, this one. Integration from a to b f of x dx. You know very well what the rule tells us. The answer for this is capital F of b minus f of a. Correct? F of b minus f of a. Correct? So then next one, I say I1. I1 is, I will take this part. Integration from a to c f of x dx. As per the rule what it tells, it is nothing but capital F of c minus f of a. Correct? F of c minus f of a. And when you come to the I2, I2 is c to b f of x dx. What the rule tells us? Capital F of b minus f of c. Capital F of b minus f of c. Correct? Yes. Now look at this. What I am going to do here is, simply I will add I1 and I2. Let I will take I1 plus I2. I1 plus I2 I will take. When you take I1 plus I2, what I will get? This number. This is f of c minus f of a plus f of b minus f of c. Correct? Now look at this. See, I have plus f of c and minus f of c, they will cancel. What exactly I am getting here? Which is equal to capital F of b minus f of a, f of b minus f of a. What exactly this one? Correct? Is it looks like I? So therefore it is I. So I1 plus I2 becomes I. So this is what we call the property number 3. Yes? Yes, please note down. Please note down. Okay? Correct? Yes. Next property number 4. Yes, property number 4. Okay. Yeah. Correct? Yes, we go for property number 4. Yeah. What is the property 4 here? So very simple. Now, little bit we will be serious regarding the property 4, 5, 6, 7 like that. Actually, earlier 1 and 2 properties and third property also, you don't feel any there is no any such special things. So okay, chalta hai properties. But 4th, 5th, 6th properties and 7th property are there. No, they are little bit easy. Okay. Yes. Integration from a to b f of x dx. हमारे पास a to b f of x dx है. कुछ नहीं होगा इसको if you write like this. What is that? Suppose you replace x, this x, by sum of upper limit and lower limit minus x, then also no change. Say for example, lower limit is a, upper limit is b. I write a plus b minus x dx. Then also the value of the function will be same. Henry sir, Henry. See, look at this. Suppose you have integration from 2 to 3 f of beta. I will take some other function. Suppose sine of 2 to 3 sine beta. We will go with algebraic. Generally domain knowledge. Yes, now look at this. See, integration from 2 to 3 f of x dx is there. Rule what it tells us, integration from 2 to 3 f 5 minus x dx is same. What an idea, sir. 2 plus 3 is 5. 5 minus x dx. Then also the value of the function is no change. Yes. Let us see the property now. Now look at the property. It is very easy property, and aram se we can do this. Solution for this. Simply what I do, I will take RHS first here. Okay. RHS. So this is from a to b f of a plus b minus x dx. And I hope you remember the property number 1. Property number 1 is called dummy variable property. Correct? So what I am interested here is, if I take this is all equal to t, then the next t to make it as x, making t to x is very easy for me. Why? Because t and x are no difference as per the first. So now what I do here, I say let us a plus b minus x equal to t. A plus b minus x equal to t. What is the derivative of this now? A is 0, b is 0. It is minus dx equal to dt. Correct? Minus dx equal to dt. And very important, when x was a, for the variable x, the lower limit was a. Now variable becomes t. Look at this. If I put x equal to a here, what the value of t becomes? A cancel, you get b. So that is t equal to b. Lower limit a tha, abhi it becomes b. Upper limit when it was x equal to b. Now look at this, put x equal to b here. What do you get? B cancel, you get a. Now it becomes t equal to a. Now very important thing, RHS takes the form is integration from a to b. This value becomes integration from b to a. Not a to b, it's like b to a aatu. Why? A becomes b, b becomes a. Limits change other notary. And also very important thing, this is all I have taken it as f of t. This is all I have taken it as t. What is dx you got here? This minus dx equal to dt plus dx equal to minus dt. So I write minus outside into dt. Correct? Property number 2 tells us. Property number 2 tells us. Don't worry if you get the minus sign. Simply interchange lower and upper limits. Correct? Simply interchange lower and upper limits. So then I will, don't worry, I simply change this one. And property number 1 tells us, don't worry, t if it comes, it is a dummy variable. Simply what you can write, a to b, e of x, dx. This is what my LHS. This is what the property number 4. Maja aitla? It's a wonderful property, beautiful property. Okay? Yes, please note down this. Slowly, 5, 6 also will do. They are also very easy property, but very important property. Important property ಅಂತ ಹೇಳಿಬಿಟ್ಟೆ ನೆನಪಿಟ್ಕೋಬೇಕು. Yes, please do fast. Correct? Very important ಅಂತ ಹೇಳಿಬಿಟ್ಟಿನಿ, ಕರೆಕ್ಟ್ ಆಗಿ ನೆನಪಿಟ್ಕೋಬೇಕು. I told you it's a very important. Next property number 5. Yes, shall we go for property number 5? Now look at this. So property number 1. Property number 5. Yes. What the property 5 tells us is, he is a brother of property number 1. Property number 4. See, if you have lower limit fixed 0 hai, upper limit any other number a, then the property what it tells us is, it is same like 0 to a, f of a minus x dx. ಮಜಾ ಆಯ್ತಲ್ಲ ಅನಿಸ್ತದೆ. ಹೆಂಗ್ ಮಜಾ ನೋಡ್ರಿ. See, if it is 0 to pi by 2 sin x dx, it is same like 0 to pi by 2 cos x dx. ಹೌದಿಲ್ಲ ರೀ? ಹೆಂಗ್ರಿ ಸರ? sin cos ಹೆಂಗ್ರಿ ಸರ? sin ಸರ ನೋ ಅಂತ. ಯಾಕೆ ನೋ? ಇಲ್ಲಿ ನೋಡ್ರಿ. Suppose if you have 0 to pi by 2 sin of pi by 2 minus x ಬರಿಬೋದಿಲ್ಲ ನಾನು? Using the property number 5. Can I write like this? Upper limit minus x. When the lower limit is 0, I can use this property, that is upper limit minus x. Where you have x, no, I can put it as upper limit minus x. Correct? What about 90 minus theta? Sin 90 minus theta ಅಂದ್ರೆ ಏನ್ರಿ? Cos theta. ಅವ್ರು ಯಾರು? ಇವ್ರೇ. Correct? So very good property ಅನಿಸುತ್ತೆ ನೋಡ್ರಿ ಒಂದ್ಸರಿ. correct ಅಲ್ಲ? When you have a 0 to a f of x dx, you can put it as 0 to a f of a minus x dx. This is a very important. And very important thing you should remember is previous property. Previous property, why is it much more important? See here, 0 plus a minus x. 0 plus a is a minus x. We are not doing any new thing here. It is just a pattern of original of fourth property. Correct? Yes. Now look at this. Yes. Then there is no any difficulty to solve this property. Why? Because you already know how to prove this property. Correct? Yes. See this proof of this property. It is RHS. You can say it 0 to a f of a minus x dx. Correct? Simply what I do, I will put a minus x equal to t. Why? I am interested in single variable x. So x you cannot write in place of a minus x equal to x only. What you can do? T you can do. Yes. ಆಮೇಲೆ ನಮಗೆ ಗೊತ್ತೈತಲ್ರಿ t ಅಂದ್ರೆ ಡೊಮೇನ್ ವೇರಿಯೇಬಲ್ ಅಂತ. ಹಂಗೆ ಲಾಸ್ಟ್ ಗೆ ಹಾಕ್ತೀವಿ ನಾವು. Let us a minus x equal to t. ಕರೆಕ್ಟ್ ಅಲ್ಲ? a ದ ಡೆರಿವೇಟಿವ್ 0. ಯಾಕೆ ಹೇಳ್ರಿ? ಕಾನ್ಸ್ಟೆಂಟ್. x ಡೆರಿವೇಟಿವ್ dx and it is d. Correct? Later on one very important thing, limit value ಬರ್ಕೋಬೇಕು. When it was x equal to 0, that is lower limit. What the value of t? Let us put x equal to 0 here. What do you get? T equal to a. So then it is t equal to a. Correct? Now ನೋಡ್ರಿ, when x equal to upper limit a, ಇಲ್ಲಿ a ಹಾಕಿದ್ರೆ ಏನು ಬರ್ತದೆ? a minus 0. So upper limit becomes 0. ನೋಡ್ಕೊಳ್ಳಿ, ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ರಿ. So for this RHS becomes 0 ಇದ್ದಲ್ಲಿ in place of 0 I have already a ಇದ್ದಲ್ಲಿ 0 ಬರಿಬೇಕು. What is this? a to 0 and a minus x becomes t f of t and we have dx minus dt. So this is minus dt. Correct? Then change upper and lower limits. What do you get? This is 0 to a f of t dt. Generally whenever you write the limits, no, lower limit will be smaller compared to the upper limit. ಅದು ಪ್ಯಾಟರ್ನ್. ಅದು ಈಗ ಏನಾರು ಹೇಳೋದಿತ್ತು ಅಂತ ಇಟ್ಕೊರಿ, ಎಷ್ಟನೇ ಕ್ಲಾಸ್ ಪಾ, ಎಲ್ಲಿಂದ ಎಲ್ಲಿಗೆ ಬಂದಿಪ್ಪ, ಲಾಸ್ಟ್ ಇಯರ್ 11th ಇದ್ದು ಈ ವರ್ಷ 12th ಬನ್ನಿ ಅಂತ ಹೇಳ್ತಾರೆ. 12th ದಿಂದ 11th ಬನ್ರಿ ಅಂತ ಹೇಳ್ತಾರೆ. ಯು ಕ್ಯಾನ್ಟ್ ಸೇ ದಟ್ ಐ ಕೇಮ್ ಫ್ರಮ್ 12th to 11th. 12th to 11th. See, you are in 11th ಅಂತ ಅಂದ್ಕೊಂಡ್ರೆ I finished 10, so I came to 11. So 1 to 11 ನನಗೆ ಯಾವಾಗೂ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಇಲ್ಲ, ಹಿಂಗೆ ಎಕ್ಸ್ಪೀರಿಯನ್ಸ್ ಯಾವಾಗೂ ಇಲ್ಲ. ಈ ತರ ಡೆಫಿನೆಟ್ ಇಂಟೆಗ್ರಲ್ you never come across in 1 to 10 standard. You never say that in 10 to 1 I never have experience. In 10th to 10th standard to 1st standard I don't have any experience. Since from morning to now, no, I am not feeling well. Now to morning I am not feeling well. What is that? So you make some opposite person, one who is sitting in front of you, he may understand your feeling what you are going to say, but the method is not correct. This is how. Correct ಅಲ್ಲ? ಈಗ ವಿವೇಕ್ ಹೇಳ್ಬೋದು, ಹಲೋ ಏನು ಆಯ್ತು ಬರ್ತೀನಿ ಕ್ಲಾಸಿಗೆ, ಹಿಂಗೆ ಅದೇ ಬರ್ತೀನಿ ಕ್ಲಾಸ್ಗೆ. ಫೀಲಿಂಗ್ ಯು ಕ್ಯಾನ್ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್, ಮೆಥಡ್ ಇಸ್ ನಾಟ್ ಕರೆಕ್ಟ್. ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಹಿಂಗೆ. ವೆರಿ ಗುಡ್. ಇವ್ರು ಯಾರು dummy variable. T is a dummy variable, 0 to a f of x dx. So he is Mr. LHS. Correct? Yes. 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 ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 5 ಅಂತೂ ಆಯ್ತು. 6 ಹೋಗ್ಬೇಕು. ಓಕೆ, 6th ಒಂದು ಚೂರ್ ಮಜಾ ಅನಿಸುತ್ತೆ, 7th ಇನ್ನೂ ಒಂದು ಚೂರ್ ಮಜಾ ಅನಿಸುತ್ತೆ, ಅಲ್ಲಿಗೆ ಮಜಾ ಮುಗಿದು ಹೋಗ್ಬಿಡ್ತದೆ. ಎಷ್ಟೊತ್ತು ಮಜಾ ಆಗ್ತದ್ರಿ ಹಂಗ. ಈಗ ಒಂದು ಕಾಮಿಡಿ ಸೀನ್ ಇರ್ತೈತಪ್ಪ, ಪಂಚ್ ಬರುತ್ತಾನೆ ಕಾಮಿಡಿ ಮುಗಿದ್ಮೇಲೆ ಮತ್ ನೀವು ಅದನ್ನೇ ಡ್ಯಾನ್ಸ್ ಮಾಡಿದ್ರೆ ಸಾಕ್ಬಿಡಪ್ಪ ಅಂತೀರಿ, ಹೌದಿಲ್ಲ? ಹಿಂಗ. ಎಸ್, ನಾವ್ ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 6. ಪ್ರಾಪರ್ಟಿ 6 ಕರೆಕ್ಟಾ? ಯಾ, ಪ್ರಾಪರ್ಟಿ ನಂಬರ್ 6. Suppose integration from 0 to 2a f of x dx. ಈಗ ಹೆಂಗಪ್ಪ ಅಂದ್ರೆ ಹಿಂಗ, ಇಲ್ಲಿ ಇಂಟರ್ವಲ್ ಇದೆ. ಲೆಟ್ us consider one interval. Every gap of the interval is a units. Okay, say for example ಈ ರೂಮ್ ಅನ್ನ ಮೆಜರ್ಮೆಂಟ್ ಮಾಡೋದಿದೆ ಅಂತ ಇಟ್ಕೊಳ್ಳಿ. Let us assume that the measurement scale is 1 desk. ನಾವು ಏನು ಮಾಡ್ತೀವಿ ಹೇಳ್ರಿ? 1 desk, 2 desk, 3 desk, 4 desk. Suppose let us we name our desk as A. 1A, 2A, 3A, 4A. Correct? So what is the meaning of 2A here? The meaning of 2A is very simple. That is 0 to A to 2A. ಹಂಗ 3A, 4A, 5A, 6A, NA. Understand? Very good. ನಿಮಗೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗ್ಲಿಕ್ಕೆ ಬೇಕಿದೆ. ವೆರಿ ಗುಡ್. ಯಾಕೆ ಅಂಡರ್ಸ್ಟ್ಯಾಂಡ್ ಆಗಬೇಕು? when there is an equal gap A is there, 0 to 2A ಅನ್ಕೊಂಡ್ರೆ what is half of that 0 to 2A? 0 to A. Correct? I do like this. The property what it tells us is it is same like 0 to A f of x dx. ಅರ್ಧ ಬರ್ತೀನಿ. And also 0 to A f of 2A minus x. ಈ ಸ್ವಲ್ಪ ಅಜಬ್ ಗಜಬ್ ಅನಿಸ್ತದಲ್ಲ? ಕರೆಕ್ಟ್ ಅಲ್ಲ? ಮಜಾ ಅನಿಸ್ತದಲ್ಲ? 0 to A you can split it as 2 intervals, but here I have taken 2A minus x dx. ಮಸ್ತ್ ಅಲ್ಲ? ಈಗ ನೋಡಿ how to prove this property. Let us look at this. Suppose we have 0 to 2A f of x dx ಅಂತ ಇಟ್ಕೊಳ್ಳೋಣ. Generally property number 3 tells us you can write like this: 0 to A f of x dx plus A to 2A f of x dx. Correct? ಸರಿನಾ? ಹೌದಿಲ್ಲ? ಪ್ರಾಪರ್ಟಿ ಹೇಳ್ತೈತ್ರಿ. ಸಪೋಸ್ ಯು ಹ್ಯಾವ್ 0 to 2A ಇದ್ರೆ ನಮಗೇನು ಪ್ರಾಬ್ಲಮ್ ಇಲ್ರಿ. ಲೆಟ್ us split into half and again other half. ಕರೆಕ್ಟ್? ಬಟ್ ಇವ್ರು ಒಂಥರ ಮಜಾ ಹೇಳತ್ತಾರಲ್ರಿ ಅನ್ಕೊಳತ್ತೀವಿ ನಾವು. ಅದಕ್ಕೆ ನಾವೇನ್ ಮಾಡೋದು? we call it as 1. The question mark is with only this one. Correct? ಇವ್ರ ಒಬ್ಬರ ಜೊತೆನೆ ಸಮಸ್ಯೆ ಐತೆ ನಮಗೆ. ಇವ್ರಿಗೆ ಸೇಮ್ ಐತೆ. This is has to change. Correct ಅಲ್ಲ? So what it has to be done now? Let us say here I will take blue color. Blue color what it takes is A to 2A f of x dx. I say it is I. Correct? ಏನ್ ಮಾಡ್ತೀರಿ ಸರ್ ತಗೊಂಡ? ಸುಮ್ಮನೆ ಯಾಕೆ ತಗೊಂಡಿವಿ ಅಂತಂದ್ರೆ I want to make it as 2A minus x. But x ಇದ್ದಲ್ಲಿ I cannot put 2A minus x. What I have to do? 2A minus t ಅನ್ನೋದು. ಹೌದಿಲ್ಲ? ಸರ್ ನಾವು ಯಾಕ್ರಿ ಒಂದೇ ಪ್ರಾಪರ್ಟಿ ಕಲ್ತೀವ್ರಿ? ಡಮ್ಮಿ ವೇರಿಯಬಲ್ ಯಾಕೆ ಕಲ್ತೀವ್ರಿ? ಸುಮ್ಮನೆ ಉಪಯೋಗ ಆಗ್ತೈತೆ ನಮ್ಗೆ ಅಂತ ಹೇಳಿ. ಹೌದಿಲ್ಲ? ಈಗ ಸುಮ್ಮನೆ ಮಾರ್ಕೆಟ್ ಹೋಗುತ್ತೆ, ಒಂದು ಕ್ಯಾರಿ ಬ್ಯಾಗ್ ಇಟ್ಕೊಂಡು ಹೋಗೋದಪ್ಪ. ಯಾವಾಗ ಒಂದು ಏನೋ ಪರ್ಚೇಸ್ ಮಾಡ್ರೆ ಯೂಸ್ ಆಗಲಿ ಅಂತ. ಇಲ್ಲ ಅಂತಂದ್ರೆ ನಾವು 10 ರೂಪೀಸ್ ಕೊಟ್ಟು ಕ್ಯಾರಿ ಬ್ಯಾಗ್ ತಗೊಂತಾನೆ. ಹೌದಿಲ್ಲ? ಇದು ಲಾಜಿಕ್ ಇದೆ. ಡಮ್ಮಿ ವೇರಿಯಬಲ್ ಸರ್ ಏನ್ರಿ ಡಮ್ಮಿ ವೇರಿಯಬಲ್ ಸುಮ್ಮ ಕಲಿಸಿದ್ರೆ ನಮ್ಗೆ ಯೂಸ್ ಆಗಲಿಲ್ಲ ಅಂತ. ಈಗ ಹೆಂಗೆ ಯೂಸ್ ಆಗತೈತೆ ನೋಡ್ರಿ, ಕೇಳೋದು ಬರ್ತೈತದೆ ಹಿಂಗ. ಈಗ ಏನ್ ಮಾಡ್ತೀನಿ? x equal to 2A minus t ಅಂತ ಹೇಳ್ತೀನಿ. ಸುಮ್ಮನೆ ನನಗೆ ಗೊತ್ತೈತಿ ಇದೇ ತರ ಬರಬೇಕು ಅಂತೇಳಿ. x t ಬೇರೆ ಬಟ್ ಮುಂದೆ ಹೋಗಿ ಒಂದೇ. ಹೆಂಗೆ ಮಜಾ ಆಯ್ತಲ್ಲ? ವೆರಿ ಗುಡ್. ಈಗ ನೋಡಿ x equal to 2A minus t ಬಂತು, ಬಟ್ ನಿಮಗೆ dx ಬೇಕಲ್ಲ. ಸೊ dx equal to minus dt. ಕರೆಕ್ಟಾ? ನೋಡ್ರಿಪ್ಪ, ಕರೆಕ್ಟಾಗಿ ನೋಡ್ರಿಪ್ಪ. ಲಿಮಿಟ್ ಚೇಂಜ್ ಆಗುತ್ತೆ. ಲೋವರ್ ಲಿಮಿಟ್ ಅಪ್ಪರ್ ಲಿಮಿಟ್ a to a ಇತ್ತು, ಬಟ್ t ತಗೊಳತ್ತೀರಿ. ಈಗ t ತಗೊಂಡ್ಮೇಲೆ ಸ್ವಲ್ಪ ಚೇಂಜ್ ಆಗ್ಬೇಕಿಲ್ಲ. t ತಗೊಂಡ್ಮೇಲೆ ಸ್ವಲ್ಪ ಹಿಂಗ ಆಗ್ಬೇಕಿಲ್ಲ, ಅಳಗಾಡ್ಬೇಕಿಲ್ಲ. ನಾವು t ತಗೊಳ್ತಿದ್ದ ಮೇಲೆ ಕರೆಕ್ಟ್ ಇರ್ತೀರಿ. t ತಗೊಂಡ್ಮೇಲೆ ಜೋಳಾಗಿ ಹೊಡಿಬೇಕು. ಎಸ್ x let x equal to a. a ತಗೊಂಡ್ರೆ t ಏನಾಯ್ತು ನೋಡ್ರಿ, ಇಲ್ಲಿ 2a minus ಸರಿ ಇಲ್ಲಿ ತಗೊಂಡಿರ್ತೀವಿ. ಇಲ್ಲಿ x equal to a ತಗೊಂಡಿರ್ತೀವಿ ಅಂದ್ರೆ a equal to 2a minus t. ಹೌದಾ? This t I will take left. This a I will take right. ಅಂದ್ರೆ ಏನಾಯ್ತು? t equal to 2a minus a. ಅಂದ್ರೆ t value also a. ಏನ್ ಚೇಂಜ್ ಆಗಲಿಲ್ಲಪ್ಪ, ಅವ್ನಿಗೇನು ಅಸರ್ ಆಗಲಿಲ್ಲ, ನಥಿಂಗ್ ಎಫೆಕ್ಟ್, t ಲಿ ಏನಾಗುದಿಲ್ಲ. ನೆಕ್ಸ್ಟ್ ನೋಡೋಣ, ಹಂಗಾರೆ ಎರಡು ತಗೊಳಕ್ ಹಚ್ಚೋಣ. ಲೆಟ್ x equal to, ನಿನಗೆ ಸಿಂಗಲ್ ಏನೂ ಆಗುದಿಲ್ಲ, ಡಬಲ್ ಹೊಡೀನಿ, 2a, ಎರಡು t ಕೊಡಿಲ್ಲ. ಈಗ ನೋಡ್ರಿ ಮತ್ತೆ ಇಲ್ಲಿ ಏನು ಹಾಕೋನು, 2a equal to 2a minus t. ಈ t ಈ ಕಡೆ ತಂದ್ರೆ 2a minus 2a 0. ವಾವ್, ಇಲ್ಲಿದೆ ನೋಡ್ರಿ, ನಮಗ್ ಬೇಕಾಗಿರೋದು ಇದೆ, ಏನು, t equal to 0. ಅಪ್ಪ, ಇವ್ರು ಏನಾಯ್ತು ನೋಡ್ರಿ, ಈಗ ಹೆಂಗಾಗ್ತದೆ ನೋಡ್ರಿ, I equal to integration from a ಇದ್ದಲ್ಲಿ ಏನ, a ಇದ್ದಲ್ಲಿ ಏನ, 2a ಇದ್ದಲ್ಲಿ 0, 0 ಬಂತಲ್ಲ 0. ಆಮೇಲೆ f of x ಇದ್ದಲ್ಲಿ ಏನು ಬರೀಲಿ, 2a minus t, ಕರೆಕ್ಟ್ ಅಲ್ಲ? What is dt? Sorry, dx minus dt. So this is all minus dt. ನೋಡ್ರಿಪ್ಪ, ಕರೆಕ್ಟ್ ಆಗಿ ನೋಡ್ಕೊಡ್ರಿ, ಸರಿನಾ? ಇದನ್ನ ನಮಗೆ ಒಂದು ಗೊತ್ತು. ಸೆಕೆಂಡ್ ಪ್ರಾಪರ್ಟಿ ಏನ್ ಹೇಳಿದೆ ಅಂದ್ರೆ, ಮೈನಸ್ ಬಂದ್ರೆ ಹೆದರೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ, ಸುಮ್ಮನೆ ಲಿಮಿಟ್ ಚೇಂಜ್ ಮಾಡ್ರಿ. ಚೇಂಜ್ ಮಾಡಲ್ದೆ ನಾವು ಬಿಡೋದೇ ಇಲ್ಲ. 0 to a f of 2a minus t dt. ಕರೆಕ್ಟಾ? ನೋಡಾಕ ಹಂಗ ಇಲ್ಲ, ಇವಳು ಸ್ವಲ್ಪ, ಇವಳು ಅವಳು ಒಂದೇ ತರ ಇಲ್ಲ. ಯಾರು ಹೇಳಿದ್ರು? ಡಮ್ಮಿ ವೇರಿಯಬಲ್. ಎಸ್, ಹಂಗಿದ್ರೆ where I have t, I will put it as x. So my job has been done now. This is from 0 to a, f of 2a minus x dx. ಶುರು ಆಗಿದ್ದೆ ಎಲ್ಲಿಂದ್ರಿ? ಇಲ್ಲಿಂದ. ಎಂಡ್ ಆಗಿದ್ದೆ ಎಲ್ರಿ? ಅಲ್ಲಿಂದ. ಅಂದ್ರೆ ಇಕ್ವೇಶನ್ 1 ರಲ್ಲಿ this part, this one, what I can replace, 0 to a f of 2a minus x. Correct alla? Yes. Now the thing is over. 0 to 2a f of x dx can be written as 0 to a f of x dx plus 0 to a f of 2a minus x dx. ನೋಡ್ರಿ ಪಾ, ನೋಡ್ರಿ, ಕರೆಕ್ಟಾ? ಡನ್ ಅಲ್ಲ? ವೆರಿ ಗುಡ್. ಟೇಕ್ ಡೌನ್ ದಿಸ್, take down, take down, take down, take down, take down, take down. ಕರೆಕ್ಟ್ ತಗೊಳ್ರಿ. ಪ್ರಜ್ವಲ್ 2 ತಾಸು ಕೈ ಮಾಡ್ತಾನೆ ನೋಡು ಮಾರೆ, ಕೈ ಎತ್ತಬೇಡ. ಎಸ್, ಪ್ರಾಪರ್ಟಿ 6 ಅಲ್ಲ 7 and 8 will prove in the next class. ಸುಮ್ಮನೆ ಗಡಿಬಿಡಿ ಮಾಡೋದು, ಯಾಕಂದ್ರೆ that 7 and 8 properties I use for the exercise. Today property, tomorrow exercise you don't understand. In the next class what I do, I will prove and I will start exercise, because the same property I am using. Even rest of the properties I am using rarely, but 7th and 8th properties I am using oftenly. Okay? Yes.